Hello, good evening everyone.
Good evening.
Yeah, so this is our second live session of the NPTEL course Symmetry and Group Theory, taken by Professor Anindya Datta from IIT Bombay. I am Shruti. I am the TA for this course and I am a PhD student in the same department. I was just waiting for a few more students to join. Last time there were 10 around. Did you guys watch the entire week 1 and week 2 contents? Yes, or you're still watching? No, week 1 you watched. Dr. Parimal Patel. Where are you from? You already have doctor. So you have done your PhD or something like that. You're still watching the course? Or from Valsad? Okay. Refreshing. Okay, okay. Nice. Week 1 completed. Okay. So did you solve the assignment? The week 1 assignment? Did you submit it? No. Okay. But you should submit the assignment before like we are going to discuss. Because I am supposed to discuss the assignments after the some questions are pending. Okay. So I'm not allowed to discuss the assignment before like the submission date. So, but actually last time I introduced the course. So today I have to discuss week 1. Okay. So let's start. Let me. So how do you feel? How is the course going? I just wanted to ask whether it is like sir is teaching very fast or very slow, or it is okay for you to catch it. It's fine. Okay. Karishma, you are master student or BSc or PhD or anything else? Master student, okay. First year? MSc first year, okay. Then it is useful for you. Okay. Honors chemistry, nice. Okay, so I'll just refresh the first week, first session. So we discussed about this question whether the molecule, which symmetry elements are present or not, and the most importantly, I don't have that slide. 1 second. Yeah. So we discussed about the most important thing we discussed in the last session was this properties of a group, that what things constitute, what properties should be there to constitute a group in itself. So it was the identity element existence, and where it is, yes, this question. So it was closure first property, associativity second, and there should be then existence of identity element and inverse element. So if these four properties are there, then that set of numbers or set of anything is called to form a group. Are you guys getting the recordings of this session or the PPT I'm uploading? Are you able to access it? Okay. Okay, fine. Raised hand, Karishma. You want to ask something?
No, ma'am.
Okay, okay. I thought you were asking something. Okay. How to find group subgroup relationship. So shall I tell you now? We will discuss this in the week 2. You have already watched. We are discussing week 1 here, Sandeep. You have to do it manually as are taught in the group. Like you have to check the elements which are forming a group within the group, then it is called a subgroup. Okay, I'll turn off my video. It's okay. Now coming to the week 1 assignment questions. So now the first question is, actually in this whole assignment we have to find the point groups of the given molecules. So in all the questions are like that only. So I'll start with the first one. This is a big molecule, and is this molecule planar or not? Can someone tell me? No. Yes, that is the first thing to identify, that this is not a planar molecule, because let me close this one. because the rings are tilted and they are not perfectly aligned in the plane of the nitrogen atom. So is it fine if I write it like is it fine if I write it like ammonia kind of N? Here this R, this R, this R, and R is this whole like pentachlorobenzene. Okay, so now can I put C3 here? It seems like I have drawn it in a planar way, but don't think this is a planar one, because these R's are angled. So this part is facing up, now this part is facing up, and it's like the tilted blades of fan. Can you imagine, like the blades tilted? It's like that. So now first look for, so we have 3 rings, so let's first look for C3. Is C3 present here?
Ma'am, nitrogen should be pyramidal, no? Pyramidal, because it is like ammonia.
Yeah.
So it should be pyramidal. Because if it is non-planar, then there will not be any resonance.
Yeah, there is one lone pair here. Yes.
Yes, ma'am. So,
Yes.
so it should be pyramidal type, no?
That's what I'm telling you. Don't think it like I have drawn it in a planar way. It's just for the representation purpose. You are getting confused because of the way I have drawn it, like in plane. No, it's not. Okay, because I cannot draw it in any other way, or I cannot show it like draw. You have to imagine it's like one lone pair is still there, but it's not planar, and I'm talking about the rings. The rings are also not in one plane, like the rings are tilted in angled. Can you imagine it now? So how shall I like these are planes different, like if it is in this one, this will be like this will be like this. Okay, the angles are different, like the perspective of the plane, if you see from one side, it will be different. Okay, so now can you apply C3 here? Can we apply C3 here? Okay, so there is a C3 like ammonia, okay, going through the nitrogen atom here. This is the C3. So if you will put a C3 directly passing through nitrogen atom, just one atom, and you will do 120-degree rotation, so these rings will change its places. So this has a C3. Okay, now look for I'll give you an example of a molecule, so it will be better to understand. Did you guys try this software? Try this app, Symmetry Autobin? It's very good one to imagine the molecules. Now see this one. Okay, now I'm giving example. This is not exactly the same question. Okay, now see how instead of these 5-membered rings in question we have 6-membered rings. Okay, see the rings are angled. When you will see from one side, you will see a different perspective. Okay for everyone? Oh, sorry. Is it okay? Can you guys imagine the molecule in question like that?
Yes, ma'am.
Okay, nice. Now, can you imagine C3? Can you draw in your notebook or somewhere? I'll show you C3. See, as I told, there is one C3 axis rotation passing through the nitrogen atom, and see how it rotates. Okay, it's like fan blades. It's just that our fan blades, mostly the old school fans, all are in plane, but here the blades are little tilted. See, this one is the C3. Okay, so in the molecule in our question, it is exactly the same. So there is a C3 passing through nitrogen. Now it is asking the point group. So is the point group only C3 or anything else is there? Who solved this question? Did anyone solve this question? Karishma, did you solve the question in assignment?
No, ma'am, I was having a doubt about C2X's.
C2, okay, yeah, it's difficult to visualize. Let's see. So I'll show you first C2. Now see this. I'll hide this C3. Can you see where is the C2 passing through? Center of the ring and through nitrogen. So in our case it will be passing through, let me have, okay, so here it will be passing through in the center of the ring and through nitrogen. So when you will do 180-degree rotation, these two will get exchanged, it will stay in its place. So now there are 3 rings, so we will have 3 C2, one this one and one for this ring. Okay,
Ma'am, that will be only possible when the rings are planar, when the nitrogen is lying in the plane, but it is tilted, it is like pyramidal now,
so that's why
because
I'm
lone pair is also there. Because ammonia is not having any C2. So this whole structure should be like ammonia, or is it planar? If it is planar, then we can imagine it is C2 is there. But
okay,
if it is like ammonia, then ammonia is not having any C2.
yeah, that is true. Yeah, let me think. Maybe they are showing it as a resonance structure. Okay, but the answer is D3, so according to it, it should have C2.
It means
Okay.
nitrogen will be in the plane, ma'am.
Then if the okay, if I'll take the case that nitrogen is in plane,
Yes,
but
ma'am.
But how the okay? But the lone pairs will be in resonance. Actually, I'm also
Yeah.
not sure whether it's planar, because if there is C2, it should be planar. You are right. It's just that the not planar, the not tetra, but I don't know. I'll confirm about this. I'll ask sir. Actually,
Okay,
I
ma'am.
also
Okay,
don't
ma'am.
know. But yeah, you are right. This is, but the answer is D3. So they are assuming that it is like a planar kind of structure. Okay, so let me show you the, yeah, according to this one, I don't know what molecule is this. Okay, this is iron. This is iron trioxylato. So C3 is there now. Can you C2 is there now? So what did you put in your assignment? It's C3 or D3?
Actually, I was confused because I thought
Mm-hmm.
nitrogen should be pyramidal, but
Okay.
as the rings are like propeller shaped now, so
Yes.
there is no possibility of resonance. So if there is no possibility of resonance, then in that case the lone pair
Should
will make
stand
it
there.
a pyramidal shape.
Mm-hmm.
Yes.
So in that
So
case, it
C3
will
should be
be
there, but yes,
C3
yes,
only.
ma'am. Yes, online I said then one e-Pathshala DU publication
Hmm?
DU that they are also giving D3, but
Yeah.
how it is coming D3 because nitrogen will not be participating in resonance if it is propeller shaped.
Yes. Yes, you're right. Okay, let me think about it. I also don't know whether what is the exact shape of this one, because the NPTL is also giving answer as D3. So I'm following that. Okay. Okay, so we have a doubtful question here. Let's see. So we can think of it as D3 as of now. Then I'll clarify it in the discussion forum or maybe in the next week. So let's keep it D3 till now. Uh, okay. So anyone else did this except Sandeep, Dr. Patel, Karishma? Can you put some insight into this? What will be the shape? Or does anyone know any software or website where we can put the molecule and get the shape? Like this one. Then it will be easier to see whether what is the exact structure. Or maybe there is still the like possibility that the structure is still debatable. Okay, there are molecules like that now where the exact structure is not known till now, so anything is possible. I'll ask someone and I'll let you know by next week. Okay, let's see the second question. This one I think everyone did, right? The symmetry elements present here. So how do we draw this? Shall I draw it like a hexagon? Oops. Sorry, my pen is very bad. Now Cl is up. Then here bromine is up. Near opposite bromine down. Then Cl down. Okay. Now what are the elements present here? C2. Is C2 present there? Hello.
Yes, ma'am. It seems C2 is there.
Where, from which axis?
Just in between. If
This
we
is
are numbering
X.
from the chlorine atom which is on the top,
Okay.
then 3 5 from chlorine on the top,
Okay.
and it is
1,
in the
2, 3.
no no yes, yes, yes.
Now tell.
Then 2 5
2,
from
5.
carbon 2 to 5. Yes, ma'am.
In
If we
the
are
plane of this hexane.
yes in the yes, it seems yes ma'am, yes. If we are rotating like opposite direction, 180-degree in
Okay,
plane.
if you will rotate in plane, so what will happen?
Then at position 3 Br is there, so C2 is not there. C2 is
Yeah, C2 is not there, I think, because when
C2 is
the
not there.
axis which I have drawn in plane, so what will happen, it will flip the positions, and here Br will go down, and here Cl will come, it will come up, and this will be Br up, and here what is left? Cl, which will be up, isn't it, in plane?
Yes, ma'am.
So C2 is not there. When you will flip it out of the plane, so actually this one is when I flipped it out of plane, so this was out of plane. I turned it like this. So this is not equivalent configuration, and in plane though definitely it is not there, because in plane when you will take here at this point, maybe you will rotate 180-degree, the position of these substituents will change, right? I mean not the positions, but these axial and equatorial will change, sorry, up and down will change. So when I'll rotate it, like suppose we are passing it through z-axis, so here down Cl will come here, up Cl will come here, and here down bromine, and here up bromine, isn't it? Did I draw correct?
Yes, ma'am. Yes.
This is fine, right? Okay, so out of plane also and in plane also C2 is not present. Okay, then sigma D, if
Sigma is
C2
not present.
if C2 is not there, then sigma D should not be present, because sigma D is like bisects to C2 axis. So if C2 is itself not there, then how come sigma D will be? Then I, then this is gone, this is gone. I
is there, ma'am. I is there.
where is it?
It is center. Center. It is passing through the center. That is point of inversion is there.
Yeah, I will be here. Okay. Now Cl. Now if we'll put I, so here we have up Cl, and when we'll go down through I, we'll go down, passing through I, down we'll find again the same atom. So this is true, correct? And now from this bromine, if I start, this is down, so I start moving up in the plane. I'll move up. Here I find bromine again. So this is also correct, and here hydrogens will be there up and down, so it has I only. So this one is the answer. Everyone got it right? So what will be the point group? What will be the point group for this one? I don't know.
Ci.
I'm
Ci,
asking you. Don't ask me. I don't know. What is it?
Ci we are saying, na? Ci.
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 Yeah, okay.
Yes, ma'am.
I'll take it for granted because I don't know. Okay. Next one. Everyone clear with this one? Karishma? Okay. Dr. Parimal gave hands up. Okay. Now, next one. The molecule that has an S6 symmetry element. Now we have to find S6. Now let's see. First I am showing you how an S6 looks like. Easier one. So for S6 we have to apply C6 and perpendicular sigma plane. Okay, suppose this is the molecule, this is complex one. Even more complex. Okay, this seems simple. See, from top it is like this. Now S6. S6 means how much rotation? How much rotation?
60 degrees. 60.
Yeah. So we rotated 60 degree and then reflected. Okay, so this is S6. Now we have to find S6 in all of these molecules. Like which has S6? Let's start with one, B2H6. How is the structure? Like this, right?
Yes, ma'am. Yes.
Okay. So these are tetrahedral arrangement 2 and joined together by bridging hydrogen. Now let's figure out what are the symmetry elements present in it if possible. Now first, it seems very symmetrical. So can you see C2?
Yes, ma'am. 3 C2 are there, ma'am.
Okay, where?
One is passing between through the two boron atoms.
Okay, correct.
And
So this is like this, right?
yes, ma'am.
Okay. this is like this. So when you will
Yes.
flip it, okay, let me write it as A and B. Okay, so what will happen, this B will go at HB will go up, correct Sandeep? This is what you
Yes.
meant?
Yes, ma'am. Yes.
Okay, so the new configuration should look like, okay, let me name this also, 1 2 3 4. Now HB, this is H4, right?
Yes, ma'am. Yes.
H1, sorry, H2, and here H1. So this is one C2. Now there is one more, will be passing through both the hydrogen atoms. So B and B are in plane, and this HA is facing, is above the plane, and this HB is exactly down the plane. So there will be one C2 which is passing through plane, like passing through the hydrogen atoms. So, I'm sorry, it is getting tilted, but, and there is no eraser also. Okay, leave it. Better. So this is like this, C2. Okay, so what will happen, these two boron atoms will change its places. So let me name it 1 and 2. So the configuration will look like, here B2. Now here this time these will stay in place. And what will happen to these H? What will be the numbers? The 3, 4 on the right hand side will come to the left hand side. 3, 4, and here 1 and 2. Okay, so this is one more C2 which moves the molecule in the plane itself. Now, so these are two C2s we covered. One more will be, let me show you here. This one is, if I write it in this direction, okay, so our molecule is in, this one will be Z, what we did, the red one is CZ, okay, the blue one, this is X, okay, so there will be one more passing through this, like this, which will be C2Y, okay. How this one will change? Hello?
All the atoms will change their position. All the atoms.
Yes,
It
in
is
this
passing through
one,
the center now.
yes, in this one all the atoms will change. Everything will change and everything will reflect. Like 4 will go to this place, B1 and B2 will get exchanged, HA and HB will get exchanged. Okay. So we have found 3 C2s in here. Now parallel to the C2s we will have planes, because everything is symmetrical. Can you imagine the plane? One will be this
Yes,
molecular
ma'am.
plane. Okay, let me draw a simple diagram and I'll show you the planes. Now this one, first one I am drawing is the plane in which both the boron atoms are there. Okay, this is one. Now another one in which the H atoms are there, the green plane. Sorry for this. Okay, so these are all straight lines, straight plane, not curved like the one I have drawn. Okay, perpendicular, two perpendicular planes, and one more will be along the third axis. Let me draw it with this one. This one will bisecting the hydrogen atoms in the other direction. Okay, everyone okay with this? So let me name this one. This one is sigma, this is x, this is y, this is z. So the red one is xy, the green one is xz, and this one is yz. ठीक है? विजुअलाइज हो रहा है सबको? 3 different planes. So we found in B2H6 we have 3C2 plus 3 sigma V's, and identity will be there obviously, and there is one more which is inversion center here. So this is there. Now there is no S6, because if you will rotate anything by 60 degree, for S6 we have to do 60 degree rotation and then perpendicular reflection. So if you will rotate anything by 60 degree, the atoms will change its places. So if you will, this is this side, if you will rotate it little bit by 60 degree, it will come here somewhere, and then even if you will reflect it, it will go down. Okay, so this is not there is no S6.
Ma'am, what is the point group in this B2H6?
That you should tell me.
This is,
You should
I
tell
think
me, right?
D2H,
C
D2H,
3C2, yes.
D2H,
D2H,
H.
because we have a molecular, and which one is the principal axis?
It is passing through the two boron atoms. C2 passing through the boron atoms, two boron atoms, because maximum number of atoms.
Okay, but there is one more C2 CZ which I have drawn, that is also passing through two atoms, right?
Yes, two atoms. So in that case, we should take the perpendicular, which is perpendicular to the plane of the molecule.
Yeah, then which one is it? The CZ.
It is
This
CY,
one, right?
CY or YX.
This one, the red one. The red one
Yes,
along the
ma'am.
z
Yes, ma'am.
axis.
Yes, ma'am.
Okay. Now the second molecule is methane. Okay. Now what is the point group for methane?
Tetrahedron. TD.
Tetrahedral. Yeah, the typical
Yes, ma'am.
example. Okay. So let's see. I won't draw it. It will be too much to draw all the tetrahedron. Methane. This I gave example in the first week also. Now you can see they have mentioned it has C3, C2, S4 and sigma planes. Now let's look. C3, can you guys imagine where is C3? Now can you see the C3?
Yes, ma'am.
Yeah, where is it? You can name the atoms passing through. C3 is passing through the bond, right? The CH bond. Isn't this C3? So how many bonds are there? 4. So we will have 4 C3. 4 C3 element, symmetry elements. Okay. Now let's see the other one, C2. So this shows the 4 C3 passing through all the bonds. Now can you imagine C2?
Yes, ma'am.
Where is it?
Passing from the opposite ways in the center.
Okay, yes, correct. This one is okay. Let me show one only. So it is like it is bisecting the two V formed by the CH bonds. Okay, and when you will see it from the other side, you can see the V changing its places. Okay, so one is this one. It would have been better if these H's are colored in different color. One is this one and one is this one. So it's along the axis. It's like XYZ axis is there na, so it's along the axis. Suppose you can take it as X, this is Y, this is Z. So we have 3. 1, 2, 3. Okay. Now next one is, now instead of S6 as asked in the question, we have S4 here. We have S4. S4 means rotation by 90 degree. And then reflection. So we have 6 such rotations. 1, 2, 3. So 3 and 3 inverse of them, total 6. But the elements, operations are 6, elements are 3. Let me play the other one. Okay. This is the last one. -90 degree and then Okay, so we have C3, C2, S4. There is no S6, and the last is sigma D. Sigma D's are passing through two pairs of CH bond. So containing two bonds and reflecting the other two. So like that we will have 3. And it is D because it is bisecting the angle between two C2s. Okay, let me show you clearly.
Ma'am, but it is containing the C2 axis, no? It is containing one C2 axis.
Okay, it is containing one, but it is bisecting the other two, right?
Okay, ma'am. Okay, ma'am.
See this one. Now is it clear?
Okay, ma'am.
So that's why these are sigma D's. So there is no S6 in here. Okay, so the other thing in the question is pH5. What is the shape of this one? pH5?
Trigonal bipyramidal.
Okay, and what about the bond lengths?
Axial will be longer than the equatorial bonds. But in real answer, ma'am, pH5 does not form.
That
pH5
doesn't
does
matter. We
not.
are doing it for practice now.
Okay.
It is not asking whether the molecule they can give you any imaginary one also. They can also write A B C D instead of chlorine bromine like that. Okay, you just know the shape and then you have to decide the elements in it. So as you guys told, trigonal bipyramidal with axial bonds longer than the equatorial ones. Now sorry, so here its point group is D3H as written here. Now let's see S3. Where is S3? Okay, it is not showing like, it is showing. Simply because these two axial bonds are same, they can get reflected, and S3 means 120 degree rotation. So we don't have S6 here. S6 would have meant 60 degree. If we will rotate it 60 degree, then the molecules will come halfway. Sorry, the atoms will come halfway. You guys get my point, right? What will happen for 60 degree? Now they have shown that there is S3. S3 means, if I'll put S3, means C3 through these bonds, PCl AClB bond C3, then these will change places. Now we have to put a perpendicular reflection. So with the perpendicular reflection like this will be the plane. So now these Cl1, 2 and 3 and phosphorus, these are in the plane, so nothing will happen to them. Their lobes may get changed, but the atoms won't change its place. So, but this Cl A and Cl B will get exchanged. Okay, so this will be B, this will be A, and the other things will be as it is, 2, 1 and 3. So this is the case of S3. But let me show you, if I'll put S6, can you draw S6 yourself? So I'm doing 60-degree rotation, C6, this will go here and this will come like this. So this is Cl1, this is Cl2, this is Cl3, this is A, this is B. So we can put S6 here. Now even if I'll put the plane and complete the operation, these atoms have already changed place, so they are not identical, like equivalent to the configuration given to us. So no S6. After the sigma plane, only Cla and Clb will get changed, right? So there is no S6. Now what are the other elements present in here? Let's finish that also. Why to leave? What are the other elements? C3 we saw.
C2 will be there.
Where is C2?
It is passing through the equatorial PCl bond and bisecting the other two equatorial bonds.
Yes. Like this. Like this?
Yes, ma'am. Yes, ma'am.
And planes? So how many C2s are there?
3 C2 and 3 sigma D also.
3 C2 for each of the PCl bond, equatorial
Yes.
PCl bond, and
Yes, ma'am.
same planes.
Yes, ma'am.
The point group is
D3H.
D3H, E, C3, 3 C2, 3 sigma V. Okay, and out of this one sigma V is this one.
Ma'am, sigma B or sigma D we will say because it is also bisecting those C2 axes.
Yes, sigma D. And the one molecular plane? You forgot about molecular plane? So the point group is, sorry, D3H. Now that's what written here, I think. That's all. Now what is the next molecule?
SF6. SF6.
So if all three doesn't contain, this one should contain, right? The molecule that has an S6 they are asking. So if other three doesn't has, this one should have. Let's see how. This doesn't has, this doesn't has, this. So this should have. Because one of the answers should be right? Let's see. Now what is the shape of SF6?
Octahedral.
Okay. Okay, so I will write it as two triangles. Take these two faces or any three at once and the other three and form a triangle. And the top one, at this S is in the center and F are at the corner of the triangle. Okay. Now if you will put axis through this, like this, okay, through this point, you mean z axis, C6 Z, okay, means 60 degree we have to rotate 60 degree, and let's say I am rotating it in clockwise direction. One, two, three. This is just for our, and this one let's write 2, 3, 4, 5, 6. So all are F atoms, so there is nothing to worry. Now let's do 60 degree rotation. Now for this one, in the clockwise direction, 3 will go here, 1 and 2, and this purple triangle, it will be 6, 4 and 5. Okay. Now since I have drawn it in two different colors, it seems like there are two different kind of tube now, but all are F atoms. Okay, so even if I'll put a plane in between, like perpendicular plane, a plane like this, so the purple triangle which is upside, it will go down. So my here the purple triangle, this is up, okay, purple is up. Now purple will go down. Six, 4, 5. And blue will come up. Only this thing will happen, but it is still the same as the original configuration because everything is fluorine. Understood? Are you guys following? So I can say it has so this molecule has S6, right? So the answer is SF6. Now again, this one is also related to octahedron, number of C3 axis. So I want you to figure it out, and I'll take 2-minute break, and I want you to do that question by the time I am back. Okay? Okay, everyone? Number of, okay, so the question is this one: C3 axis in octahedron, and you have to draw all. Done? The answer was right there. I have given you the answer here. So there are 1, 2, 3, 4. 4 C3 axis. Okay, for the last question, I'll show you the S6. Only one. So as I told you, draw two triangles up and down, in like one is the apex is facing up and in the other one it is facing down, and pass a C6 axis from the center and then do the reflection. Okay, so that's how there is S6. Now let's see a proper octahedron. So this is an octahedron. Okay, why it is octahedron when it has only 6 vertices?
8 faces. 8 faces.
Yes. Now let's see C3. So it is passing through the diagonally opposite faces. So it has 8 faces. So diagonally opposite pairs will be 4. So there will be 4 such C3s. It is little difficult to visualize, but you can see that this face is a triangle. Okay, all the face is triangular. So when you will pass through the center of one triangle, you can see. Okay, so like that there will be others, diagonally opposite faces. Okay, these are the 4 C3s. So for this one, answer is 4. Now again this one. The point group. What is the shape of this molecule?
Is it a tetrahedron?
Okay, they have drawn it. Yes. And symmetry elements?
It is not very clear, but I have put S4.
Okay. If it is tetrahedral, then why the point group is not TD? Tetrahedral itself. Okay, let's see C2. Let me check whether there is any example of such molecule. S4 actually is the answer given. Okay, the molecule is given here. So this is the molecule, right? Can you see? I think this is the same molecule given. We need to check the bonds. Now the pink atoms are CO, cobalt, Okay, one CO is connected to 3 COs and one CP ring. This cobalt is connected to 1, 2, 3 and this one CP ring, and there is one difference, I think. This bridging thing, it is not given here, or I forgot the transition metal chemistry. Does the solid bond means a bridging thing?
It may have metal-metal bonding or something.
But I thought of taking example of this, but it may be a different molecule. They have not in the question it is not drawn clearly what the molecule is. Let's take it like this only. Seems pretty similar. Okay. Now S4 we have to check. Okay, it has C2, S4 only. Where is C2? This is a difficult one. There is only one C2. Okay. There is only one C2 passing through the center of the bridging ones and this one. Let's see. Okay. Okay. Did you guys get it? There is only one C2. First I thought there will be many C2s, but the geometry is such that these two bridging ones are on the same side, and on the opposite, when you will see the down face, these two are on the opposite of the front one. So there is only one C2. This one is coming here, and the other things are like methane we saw. You can think of it as a CH bond. The other things are rotating like two inverted V's of the CH bond of the methane molecule. These two are getting exchanged, these two are getting exchanged. Clear? Now let's see where is S4. At same axis. S4 now you can visualize, right? You have to reflect it by, rotate by 90 and then reflect. So now if this molecule is same as given in the question, then the answer should be S4. There is no C4. There is C2 and S4. If C4 had been there, then only one operation would be possible out of two, the S4, right? The first one, see, the molecule will stop at this point. Yes. Can you see? If I will apply C4, then only this much will happen. From here to, from original position to this like translucent phase. From here to here. So this is not equivalent. So C4 is not there. Now what else? If C4 is not there, then it can't be D4, okay? So this is wrong. Now C2 is there, S4 we saw, C2H and V. Now we have to look for planes, whether any planes are there or not. Now see, if I'll consider this plane itself, when you will reflect those things, see, they are not reflecting, anything is not reflecting. This one is towards you, towards the screen. This one, this face is facing back of the screen, right? This one, these two down ones, this is towards the screen, this is facing towards the back of the screen. So the planes, when you will put the reflection plane, this will come here, this will go here, but the configuration will not be the same. It will change. The faces of these CP rings, it will change. So planes are not there. Okay, so I think only C2 and S4 are there. Okay, so this is not there, plane, no planes. So C2 is also, C2H is not there, C2V is not there. So our answer should be this one only, S4. Okay. Okay. Okay, this question is conversion of boron trifluoride to tetrafluoroborate accompanies increase in symmetry and bond elongation, increase in symmetry and bond contraction, decrease in symmetry and bond contraction, decrease in symmetry and bond elongation. What is BF3 shape?
Triangular.
Yes. Now this is in plane. Okay, and we know the point group.
D3H.
Now we have to convert BF3 to tetrafluoroborate. This one. Now we have to add an ion, F minus we have to add. Then the shape will become it will be a coordinate bond okay. What will be the shape of this one? Tetrahedral, right? Now, how many? So this is an increase in symmetry or decrease in symmetry?
Increase in symmetry.
How do you say that?
Because earlier order was 12, but now it became to 24.
Okay, so here it is order, that is the number of operations 12, and here it is as We said it is 24. Now extra elements are also, symmetry elements are also added, right? In D3H, what elements do we had? So we'll have C3, we'll have 3C2, and it is H, so there will be sigma H, there will be 3C2 and 3 sigma V, okay, and there will be for BF3 there will be S3 also. You will do 120-degree rotation and then reflection through the molecular plane. Now for tetrahedral, it has one C3, but this one will have 4. Okay, and how many C2s? 3 C2, I think. There will be S6 also. So it is getting the number of elements are increased here. What else? E and E are there already. How many? Sorry, S4. There will be 6, I think. 6 S4. So total order is number of operations, not the number of elements. So number of operations will be 24, and for this one it will be 12. Okay, for C3 it will be producing 2 operations. C2 1 2 operations. Sigma H 1 2. S3 inverse 2. Okay, so there is an increase in symmetry. And the other question is bond elongation and bond contraction. So it is asking about these BF bonds. What happens to the BF bond when an extra F minus is attached to it?
Bond contraction.
Why?
Ma'am, because now the effective nuclear charge of boron has to be shared to the 4 fluorine atoms. So there will be the contraction of bonds from the other 3 fluorine atoms.
Okay. And what about the change in the hybridization?
Yes, ma'am.
So you get it now. There will be change, and there is a thing called back bonding. Back bonding will also affect, right? So when it was in this configuration, boron had vacant orbitals, and F can donate its lone pair to it. Right? I think the answer should be based on the back bonding thing. The back bonding will not be possible here in the BF4 thing. This is a prominent example of back bonding, right? You guys must be studying this one. So when this donates a lone pair into its vacant orbital, the character of this bond becomes like a partial double bond. All these. So for a partial double bond, the bond length will be shorter, usually shorter. So if I go for numbers, the bond length for this one is around, I think, 130, and this one is 143 according to internet sources. So bond elongation is happening because back bonding is getting like now we have stopped back bonding because it's orbitals p, or there is no vacant p orbital now, so there is no back bonding. So this is purely single bond which should be longer. This was partial, it had partial double bond characters, so it was shorter. So the answer should be increase in symmetry and bond elongation. First one. Okay, the next one is number of C2 axis in CCl4. I told just now only. How many will be there? Four. Passing through
Opposite V's.
so how you will make 4 pairs of opposite V's? You can make only 1, 2 and this one 3. You can make only 3 pairs, right? Karishma, did you
Yes,
answer?
ma'am. Sorry by mistake. I thought it to be another element.
It's okay, it's okay. No need to be sorry. So there are 3 C2s. And instead of H here, we have all Cl. So this will be tetrachloromethane, CCl4. 1, 2, 3. So I'll just tell you how do you see. First take these two, one V pair and this one is the other V pair. Okay, so we have one C2, this one. Right side 2 and this side 2 as the V pairs. Okay, so this one is C2. And next we will take the 2 up one, these two, and 2 down one. So for that we will have this one, this C2. Okay, and third combination will be this one, the left and right ones and the up and down ones. Left and right ones as one V and the up and down ones as one V. So when I'll put it like this, you can see the other C2. Okay, along the axes. Fine, we cannot make any other pair for C2. Okay, so let's get back to the Next question. Now point groups of this one and this one. Did anyone solve this question? So you can see that these two planes, as they have drawn in different, they have in different shapes they have drawn. Both are hexagon, but one is in one plane and the other one is in perpendicular plane. I'll draw this thinner, and this one is in perpendicular plane. Now BR COOH okay. Does it has C2? Because all the options have C2 in them. It should have C2. Check along the axes. Now suppose if I put one C2 along the x-axis like this, okay, so what will happen? This, for this one, it will come out of plane. No, sorry, 180-degree rotation, right? So if I'll put C2, this will go there, this will come this side, and same opposite will happen here. Okay to visualize? Bromine will come here, and here will be acid group, and here bromine will go up, and here will be acid group. So this is not the equivalent configuration, so this C2 is not present. Let's see the other direction. If I'll put along the Y in this direction, now what will happen? The rings will change places. Okay, and it will be, for this one it will be out of plane rotation. This will go here, this will go here. Okay, the rings, the sides will change, and so the substituents will change their places. Like if I'll change, BR will come here, here COH will go. And the third plane, if I, third rotation axis, if I put, which is along the Z. I think is the Z one there? C to Z?
It is not there, ma'am. Not there.
Okay, yeah. But there should be some C2. All options are C2. Where is it?
Yes, C2 is there. If we are joining two CWH group, then we have to do some inclined rotation.
Inclined C2 wave, because it is not along the Z, not along the X, not along the Y. Yes. Let
It
me
is like the Aline case, ma'am. Aline is there, na? Aline.
if yes,
Aline.
if we'll put it like this, the planes should change their orientation. The one which is in plane should become perpendicular to the plane. So I think this is the direction, right? If you are rotating it through this, we are rotating it like this 180. Is it okay to visualize? No, na? Let me look for some molecule.
Ma'am, D2D point group that Aline is having, na? Aline, if you are showing Aline, then it will be clear.
Okay. Yes, in Aline also those. Yes, you are correct. Like this. So this C2 will be like this. Okay, this is in axis. It has extra C2s because the substituents are same, but for us the position of those substituents are different. I think this C2 is there. Yes, this one. Like this we have to put a C2. We have to keep the molecule in the planes in X, and it should go in between the X. Okay, so this is it, the yellow one. So this will come above, and then let me draw it. I think I cannot draw it, but it's okay, right? Everyone is able to understand this one, right? I'll play again. So for us, instead of these two bonds, we have one benzene ring here, one benzene ring here at different planes. Okay, so it has only one C2, and the next one, let's do the next one. This is a coordination compound. So if I'll draw it in this way, I'm just changing the angle of my drawing. I'm drawing n here, and then this down CL will come here. I'm not performing any operation here, I'm just changing the angle of the way it was drawn in question. So I think now I can see the C2. Where is the C2? Can you guys see?
It is bisecting the two chlorine atoms and two nitrogen atoms and passing through M. It is
Bisecting.
bisecting two chlorine atoms angle, that B of chlorine
You are asking like
and
this? Two C2s.
no, it is bisecting the Cl and Cl bond. It is bisecting and passing through M.
Yes,
That
yes, now you are right. Okay? So this is also same as that case. One is up, one is down. This will come here, this will go there, and these two will change. The rings will change. The upside will go downside, down will come up, and this is the C2. This is not along any XYZ direction in the plane. Okay, so I think the answer is C2 and C2. There is no plane, is there? If we will put plane here, there is CL. If we will put plane like this is up, this is down, so they won't reflect. If I'll put plane in the Y direction, if I'll put plane on this C2, then also it's not possible because this has to go down. Plane will just make it like this, up. So plane is not there. Okay, so the answer is C2 and C2, I think.
Ma'am,
Yes?
also it is a chiral molecule. It is a chiral molecule. We two are chiral molecules. So here only optical isomers exist in both cases. So in case of optical isomers, we generally do not take any planar symmetry or any vertical plane.
Yes, that is also true. Nice. Nice point you made. So the answer is C2 and C2. Okay, so I think we reached the end of the questions. And these are the questions I gave you last week for assignment. Like just for practice, not assignment. Assignment we are discussing. So you try to solve these. Did anyone try these? Okay, if not, you can try, and this is just for your practice. So we covered all the questions. There are only this many questions in week 1, right? Okay. So shall I close the session? I'll share this PDF. Okay, so you try those questions and then yes, thank you Sandeep for joining, thank you Karishma, thank you Mr. Patel. Okay, thank you for joining everyone, and we'll meet next week for we'll discuss then second week assignments. Good night everyone.